Hello students. So today we are going to start a new topic, that is complex numbers. This is a very important topic as far as JEE as well as any other entrance exam is concerned, and we are going to study this topic in detail so that you can work on any type of problems based on complex numbers. So we are just going to master this complex number. So let's start complex numbers. So as you know, a complex number is z is equal to a plus ib. A complex number is a number of the form z is equal to a plus ib, where a is called the real part of z and we write it as re of z. And b is called the imaginary part of z and it is denoted by im of z. Okay, so z is equal to a plus ib, where a is the real part of z and b is the imaginary part of z, and this is how we represent a complex number. Now, sometimes what happens is your b will be equal to 0. So if your b is equal to 0, what happens? Your complex number will be z is equal to a. Since b is 0, I into 0 will give you 0. So z is equal to a. In this case, we say that the complex number is real. So we can say that a complex number is a superset of a real number. So we can write a real number is a subset of complex number. Now, if a equal to 0, we get z is equal to ib. So in such a case, we say that the complex number is purely imaginary. So always note, a complex number is said to be purely imaginary if a is equal to 0. Now, what is the value of this I? I is nothing but root of negative 1. We call it iota. Okay, iota is root of negative 1. Now, let me just explain what are the powers of I. How will you find out the powers of I? I raised to 1 is I only, which is equal to root of negative 1. Now, I square is negative 1. I cube will be negative 1 into I, that is negative I raised to 4 is equal to 1. So, the powers of I is I, negative 1, negative I and then 1. So, these are the powers of I. We can write any power of I using these four powers of I. Say for example, if you want to write I raised to 32, how can you write it? I raised to 4 the whole raised to 8. A raised to m the whole raised to n is a raised to mn. So I raised to 4 the whole raised to 8 is I raised to 32. So this is equal to 1 raised to 8, which is equal to 1. So like this, you can find out any power of I. So always note the four consecutive powers of I. If you find out the sum of four consecutive powers of I, you will get 0 because one of them will be definitely I, second one will be minus 1, third will be minus I and last one will be 1. So always note the sum of the four consecutive powers of I is equal to 0. So I can write it as I raised to 4k plus I raised to 4k plus 1 plus I raised to 4k plus 2 and I raised to 4k plus 3. When you add the four powers of I, the sum will be equal to 0. I hope it's clear. And also, any number can be written as I raised to 4k or I raised to 4k plus 1, I raised to 4k plus 2 and I raised to 4k plus 3. I hope it's clear so far. Now, we are just going to study the algebra of complex numbers. What is algebra of complex numbers? How to add, subtract, how to equate to complex numbers, how to divide to complex numbers, or how to multiply to complex numbers. All these things that's what we are going to study now. Now, how to add two complex number. Let me just take an example and I'll explain. Algebra is first one is addition of two complex numbers. Let's take an example. Z1 is equal to 2 plus I3 and Z2 equal to 4 plus I6. Let's add these two complex numbers. What do we get? Z1 plus Z2 will be 2 plus 4, that is 6, plus I into 3 plus 6, that is 9. So 6 plus I, 9 is the required complex number. Don't cancel out the common factor. The answer is 6 plus I9. Okay. Now, next one is subtraction. How to subtract two complex numbers? Z1 minus Z2. I'm going to use the same complex numbers. So let's subtract the real part. So 2 minus 4. 2 minus 4 is negative 2 plus I into 3 minus 6. 3 minus 6 is negative 3. So we can write it as minus 2 minus I3. So this is the required complex number. Now, if you want to multiply two complex numbers, while multiplying, we have to use I square. There will be a term with I square. So we know that I square is equal to negative 1. So let's multiply these two complex numbers. Z1 into Z2 is 2 into 4, that is 8. 2 into 6, that is 12y. Then 3i into 4, it's again 12y. Then plus I square into 3 into 6, that is 18. So we have 8 plus 24i and minus 18. So 8 minus 18 will give you minus 10 plus 24i. So always remember, if you want to multiply two complex numbers, we just have to FOIL and rewrite I square as minus 1. Clear? Now, let's just look at how to divide two complex numbers. While dividing two complex numbers, say for example, if you want to divide say 2 plus I3 by 4 plus I6, we need something called conjugate of a complex number. So conjugate of a complex number. See, suppose Z is equal to A plus IB is the given complex number. Z bar will be A minus IB. So that is the sign before I has to be changed. That is, if it is positive, you have to make it minus. And if it is minus, you have to change it to positive. So now, can you tell me what is the conjugate of I plus 1? The conjugate of I plus 1 will be, it's not I minus 1. Please note it is minus I plus 1. So wherever you find I, the sign before that has to be changed. Okay. So now to divide two complex number, what we need to do is we have to multiply by the conjugate of the denominator in numerator as well as denominator. Why we are doing this? We are just going to write the complex number in the standard form. Now, what is the standard form? Standard form is nothing but A plus IB. A plus IB is the standard form. So, what I am going to do is just multiply by 4 minus I6. As you know, 4 minus I6 is the conjugate of denominator. So, we are just going to multiply and divide by 4 minus I6 in the numerator as well as denominator and simplify and write it in the form A plus IB. So, that will get a complex number in the standard form. Let's just multiply 4 minus I6. When divided by 4 minus I6, we get the required complex number. Let's simplify this. So what do we get? 4 into 2 is 8 minus 12y plus 12y minus I square into 18. So minus of I square is negative 1. So plus 18 divided by, what do we get? Here the number is 16 minus I square. I square is negative 1, so plus 36. So what do we get? Here 12y and 12y get cancelled. So we'll get 26 divided by 52, right? 26 divided by 52 is nothing but 1 by 2. So the complex number, when you multiply this, we are just getting 1 by 2. Does it mean that it's just 1 by 2? Yes, it's actually 1 by 2 plus 0i. The real part is 1 by 2 and the imaginary part is 0. As I had already explained, this is a real number. It's not purely imaginary or it's a complex number. It's a real number. So that's why there is no imaginary part for this complex number. I hope it's clear. Now, we need to study a few properties of conjugates also. So please note conjugate, properties of conjugates, properties of conjugates, properties of conjugates. See, as you know, if Z is a given complex number, say A plus IB, and Z bar is A minus IB, first thing what we have to know is say Z1, suppose Z1 is A plus IB and Z2 is X plus IY, This is Z1 bar. Then what will be Z2 bar? Z2 bar is X minus IY. Always note Z1 plus Z2, the whole bar will be same as Z1 bar plus Z2 bar. So this is one of the important properties. So look at this. Z1 plus Z2, the whole bar. That means Z1 plus Z2. Let's just add A plus X plus I into Z1 plus Z2. I'm just writing Z1 plus Z2 equal to A plus X plus I into B plus Y. Now, what is the conjugate of this? Z1 plus Z2, the whole bar is A plus X minus I into B plus Y, right? Now, let's just find out what is Z1 bar. Z1 bar is A plus IB, sorry, A minus IB, and Z2 bar is X minus IY. When you add these Z1 bar plus Z2 bar, you're getting A plus X minus I into B plus Y, the same thing. So we can say that Z1 plus Z2, the whole bar is Z1 bar plus Z2 bar. Clear? Now similarly, Z1 minus Z2. Okay, Z1 minus Z2, the whole bar is Z1 bar minus Z2 bar. Similarly, Z1 bar, the whole bar is Z1 itself. Now, Z1 by Z2, the whole bar is Z1 bar by Z2 bar, provided Z2 must not be equal to 0. It must not be any 0 complex number. Okay, so then only we can find this. I hope it's clear. Now, there is something called polar form. Okay, so polar form is very important as far as like some competitive exams like JEE Mains. So let me explain what is polar form or modulus amplitude form. It's just a different representation other than standard form. Polar form or modulus amplitude form. Okay, modulus amplitude form. Now, why we call it polar form or modulus amplitude form? Always note, we are using, the form is actually like this, Z is equal to R into cos theta plus I sin theta. This is how we are going to write any complex number using these two variables, that is R and theta. This R and theta are called polar coordinates, and that's why we call this form polar form. Since these are polar coordinates, we call polar form. And also, this R represents the modulus of the complex number, and theta represents something called argument or amplitude of a complex number. Let me explain what is modulus and amplitude. See, if you have a complex number, and usually in complex numbers, we call this Cartesian plane as Argand plane. And this is the real axis and this is the imaginary axis. So instead of x axis, we call it real axis. And instead of y axis, we, we call it imaginary axis. If you have a point, say somewhere here, which is xy. Okay, suppose you have a point xy. The distance from the origin to the point xy is called the modulus. It is usually denoted by r. R is nothing but r is equal to modulus of z. And now how do you find it? Mod z is equal to root of x square plus y square, which is nothing but the distance from origin to the point xy. So r is equal to mod z, which is equal to root of x square plus y square. And argument is the angle which it makes with the x-axis. Okay, argument is the angle which it makes with the x-axis. Now, how do we measure this angle? If your complex number is in the first and second quadrant, we'll measure it like this. Okay, in this direction. And if it is in the third and fourth quadrant, we'll measure like this, in this direction. Okay, so that's very, very important. So always remember, this amplitude is obtained as theta equal to tan inverse modulus of y by x. Okay, tan inverse modulus of y by x, where your complex number is z is equal to x plus I y. So we'll just find out theta as tan inverse modulus of x plus y, y by x. Now, how will we represent the angles and the R in each quadrant? I'll tell you. See, if our complex number is in the first quadrant, how will you understand that our complex number is in the first quadrant? Obviously, x and y has to be positive, right? When x and y are positive, we can say that our complex number is in the first quadrant. Second quadrant, x will be negative, y will be positive. Third quadrant, x as well as y has to be positive, sorry, negative. And in the last quadrant, x positive and y negative. Let me tell you once again, x positive and y positive in the first quadrant. Second quadrant, x is negative, y is positive. Third quadrant, both are negative. And last quadrant, x positive, y negative. Okay. So using this, we can understand whether a complex number is, what do you say, in which quadrant. Okay. So if a complex number is in the first quadrant, we'll write this theta as it is. The argument or amplitude is obtained by theta is equal to tan inverse modulus of y by x. If it is in the second quadrant, we'll write pi minus theta. If it's in third quadrant, we'll write minus pi plus theta. And if it is in the last quadrant, we'll write minus theta. And always remember, a theta will lie between minus pi and positive pi. It will never assume the value minus pi. It will be between minus pi and positive pi. Positive pi is a value which it can obtain, but it can never become minus pi. Okay, why? Because we are measuring like this. Okay, now let me just give you an example. Say for example, z is equal to 1 plus I root 3. Suppose this is our complex numbers. Let's try to find out what is the modulus amplitude form of this complex number. So let's first find out the modulus. Modulus is mod r is equal to root of x square. What is instead of x we have? 1. So 1 square plus root 3 square, which is equal to 3. So we have root 4, which is equal to 2. So root 4 is 2. So we already got the modulus. Now this complex number is in first quadrant. Here x and y both are positive. So our complex number is in the first quadrant. So directly whatever theta we get, that is what we need to write. So theta is equal to tan inverse modulus of root 3 by 1. What is root 3 by 1? Root 3 by 1, root 3 itself. So tan inverse root 3. What is tan inverse root 3? Tan inverse root 3 is pi by 3. So how can you write this complex number? This is your theta and this is your r. So we have to write the complex number is in this form. So z is equal to cos r into, sorry, r is 2 into cos pi by 3 plus I sin pi by 3. This will be our required complex number. 2 into cos pi by 3 plus I sin pi by 3. And this form is called modulus amplitude form or polar form, right? Modulus amplitude form or polar form. I hope it's clear, right? Now, there is one more form which is called Euler form. Okay, Euler form. Let me just give you a small hint on that also. Euler form is nothing but Euler. Even if we say Euler, the spelling is E-U-L-E-R. Euler form is R into e raised to I theta, where e raised to I theta is nothing but cos theta plus I sin theta. So we can write it as R into e raised to I theta. So here 2 into e raised to I pi by 3. This is how we write the complex number in the Euler form. Clear? So this is Euler form, this is polar form, and already what we studied a plus ib was nothing but standard form. So these are the three different forms of complex numbers. Now, let me explain one more thing, that is cube root of unity. How to find out cube root of 1. Okay, as you know, how to find out the square root of a number? Square root of 9 is plus or minus 3, right? But when you say cube root of 27, we just say the number 3. Okay. So far we were studying and we were just saying only one cube root. But there must be definitely three cube roots. And we were not saying the other two cube roots just because they were complex numbers. And as we were in the 10th standard, we never knew what is a complex number. Is there any number, imaginary number? We always say in 10th standard, if your if a quadratic equation has discriminant less than 0, what we say is there is no real solution. We'll never say that there is an imaginary solution. But now we can say that if b square minus 4ac is less than 0, definitely there is an imaginary solution. And that imaginary solution is nothing but a complex number. Okay. So now we can say that we can find out the cube root of unity. So cube root of unity means which are the three roots of unity. That's what we are going to find out now. So let's assume z is cube root of unity, cube root of 1. So we can, when you cube both sides, we can say z cube is equal to 1, or we can write z cube minus 1 equal to 0. Now this is of the form a cube minus b cube. As you know, a cube minus b cube is a minus b into a square plus ab plus b square, right? A square plus a square plus ab plus b square. So using this, we can write this as z minus 1 into z square plus z plus 1 equal to 0. Now from this, one of the root that we are getting is z is equal to 1. And this is the root which we usually used to say. And then z square plus z plus 1 is will give you a complex root. Not one complex root, we'll get two complex roots. And these are the other two roots of unity. Okay, so total three roots will be there. So z is equal to minus 1 plus or minus root of 1 minus 4 divided by 2. Or we can write minus 1 plus or minus root of negative 3 by 2, which can be written as minus 1 plus or minus I root 3 by 2. And this has got lot of peculiarities. One thing is that one of the cube root is the square of the other. Okay, in both cases. Say for example, to maintain the standardization, we usually take this as omega. Omega is equal to minus 1 plus I root 3 by 2. This is usually taken as omega. And omega square is minus 1 minus I root 3 by 2. And these cube roots have lots of peculiarities. First thing is that when you add these three complex numbers, we'll get 0. Just look at this. 1 minus half minus half. 1 minus half and minus half is 1. 1 and 1 will get cancelled and we'll get 0. Similarly, plus I root 3 by 2 minus I root 3 by 2 will get cancelled and will get 0. So we can say that 1 plus omega square is equal to 0. This is one of the peculiarity. And omega is obviously the cube root of unity. So we can say that omega cube is equal to 1. So like as in the case of I, powers of I raised to 4 is 1. Similarly, omega cube is 1. So any third power of omega is equal to 1. Omega cube, omega raised to 99. Like that, omega raised to a third power will be definitely equal to 1. That's the second peculiarity. Third thing is that conjugate of omega, omega bar will be nothing but omega square. Similarly, omega square bar will be equal to omega. 1 by omega will give you omega square. 1 by omega square will give you omega. So these are, we have more peculiarities, but still I've listed a few of them. So 1 plus omega square is 0, omega cube is 1, omega is the conjugate of omega square is the conjugate of omega, 1 by omega is omega square, and 1 by omega square is omega. And also, when you plot omega square and 1 on an Argand plane, you'll get an equilateral triangle with one vertex at 1. Okay, so please note it, you'll get an equilateral triangle. Now, then there are few questions which we get to find out the locus of a complex number. Whenever you're asked to find out the locus of a complex number, you just have to replace z is equal to x plus iy and proceed whatever is given in the question. Usually the questions will be very lengthy, but when you work out, it will be very simple. So always try to read the question. Okay, so that's a very important thing that you have to note. Okay, so in complex numbers, you'll get lengthy questions, but if you read, there'll be nothing in that question. So this is a very simple chapter if you just look at like this. Now, how to rotate a complex number. Suppose you have a complex number. Say z is equal to say r into cos theta plus I sin theta. And if you want to rotate this complex number through an angle alpha in the anti-clockwise direction. So suppose your complex number is here, and if you want to rotate it like this in the anti-clockwise direction, okay, towards this side. In that case, and if the angle is alpha that you want, you just need to multiply by cos alpha plus I sin alpha. Okay, cos alpha plus I sin alpha. So if you multiply a given complex number by cos alpha plus I sin alpha, it will get rotated to uh, it will get rotated in the angle alpha in the anti-clockwise direction. Okay, anti-clockwise direction. Rotation in anti-clockwise direction, angle will be alpha. But if you multiply this complex number by cos alpha minus I sin alpha, it will get minus I sin alpha, it will get rotated in clockwise direction. Okay, clockwise direction. Angle will be same, angle will be alpha. Okay, so this is what we have to remember. Again, you can stretch and shrink the complex number just by multiplying by a constant. If you multiply by say 2, your complex number will get stretched to 2 distance. So suppose your complex number is here, and if the distance is 1, if you want to that is stretch it, you just have to multiply by 2. If you multiply by a fraction, it will get shrinked or contracted. Okay, now let's just try to work out some problems based on complex numbers. So this is our first question, which this appeared in uh, JEE Mains. Okay, so let's try to work out this complex number. We are given that let p, q be real numbers, and 1 minus root 3i, 1 minus root 3i, this I has to be outside the root, 1 minus root 3i, the whole raised to 200 is equal to 2 raised to 199 into p plus iq, where I is root of -1. Then p plus q square and p minus q plus q square are the roots of which of the following equations. This is what we have to find out. So I'm just going to write this complex number in the modulus amplitude form. Okay. And I'll explain how to find out the power of a complex number. The power of a complex number is obtained by something called De Moivre's theorem. I'll explain that one. So suppose you have a complex number like this, cos theta plus I sin theta. And if you want to find out the whole raised to n, you can find it as cos n theta plus I sin n theta. And this is called De Moivre's theorem, I sin n theta. Okay. And we are going to use this here. So, and if it is cos theta minus I sin theta the whole raised to n, we'll write cos n theta minus I sin n theta. Okay. So let's first write this in the modulus amplitude form. Can you tell me what is the modulus? Modulus is nothing but root of 1 plus 3, right? So here modulus is the root of 1 plus 3, which is equal to root 4, that is 2. We got the modulus to be 2. And amplitude, tan inverse modulus of root 3 by minus root 3 by 1. So which is nothing but pi by 3. But this complex number, this is in which quadrant? X positive, Y negative. So this is definitely in the fourth quadrant. Fourth quadrant means we'll write minus pi by 3. So the complex number is 2 into cos pi by 3, cos of minus pi by 3, right? Cos of minus pi by 3 is cos pi by 3, and plus I into sine of minus pi by 3 is minus I sin pi by 3. So we'll write cos pi by 3 minus I sin pi by 3. So this is the polar form of this complex number, and we have to write this raised to 200 equal to 2 raised to 199 into p plus iq. So let's just try to compare the real and imaginary parts, and then find out what is p and q. For this, what I'm going to do is just expand this 2 raised to 200 and 2 raised to 199. So it will get cancelled and we'll get 2 into cos 200 pi by 3 plus I sine 200 pi by 3 equal to P plus IQ. Okay, I sine 200 pi by 3 equal to 2 P plus IQ. 1 2 raised to 9, 199 and 2 raised to 199 cancelled and we just got 2. Clear? Now, 200 by 3. How can you write 200 by 3? 200 by 3 is nothing but 200 by 3 is nothing but we'll get 66, 66, right? 18 and we'll get again 6 times 18 and we'll get 66 into 2 pi by 3. So let's write 200 pi by 3 can be written as 66 pi plus 2 pi by 3. So this is actually 33 rotations. So we can just omit it and directly we can write 2 into cos 2 pi by 3 plus I sine 2 pi by 3 equal to P plus IQ. Okay. Now, what is cos 2 pi by 3? Cos pi minus pi by 3, right? Cos pi minus pi by 3 is minus cos pi by 3. So let's rewrite this as, let me erase this part, okay? Give me a second. Let me erase this. Now we can write cos 2 pi by 3 like this, 2 into minus cos pi by 3 plus I sine pi by 3. Is it clear? Because sine 2 pi by 3, sine pi minus pi by 3, sine 180 minus theta is sine theta. So we can write plus I sine pi by 3 and then equal to P plus IQ. Okay. And remember, here we had minus only. So this will be minus. This is also minus and we'll get minus here. So minus cos pi by 3 minus sine pi by 3. So let's compare. What is the value of minus cos pi by 3? Minus cos 60. How much is that? Minus 1 by 2. So we have minus 1 by 2 minus I root 3 by 2. So let's compare P and Q. What is P and what is Q? 2 cancels. So this is minus 1 minus I root 3 equal to P plus IQ. So P is negative 1 and Q is minus root 3. So P square, sorry, P plus Q square is negative 1 minus root 3 plus 3. So what do we get? We get 2 minus root 3. And P minus Q plus Q square is negative 1 plus root 3 plus 3. So what do you get? 2 plus root 3. Now we want the sum and product. Sum is actually 4 and product is, sum is 4 and product is 4 minus 3, that is 1. Product is 1. So whenever we have sum and product, how will you write the equation? The equation is actually x square minus sum of the roots into x plus product equal to 0. So we get x square minus 4x plus 1 equal to 0. Okay, so x square minus 4x plus 1 equal to 0. So the required answer is option 1. So our next question. Now, our next question is the value of 1 plus sine 2 pi by 9 plus I cos 2 pi by 9 by 1 plus sine 2 pi by 9 minus I cos 2 pi by 9 the whole raised to 3. So this is what we have to find out. Now, what I'm trying to do is, let me take the complex number z equal sine 2 pi by 9 plus I cos 2 pi by 9 as z. Okay, I'm just going to take it as z is equal to, let z is equal to sine 2 pi by 9 plus I cos 2 pi by 9 as z. So what will be z bar? Z bar will be sine 2 pi by 9 minus I cos 2 pi by 9. So I can write uh, this complex number as 1 plus Z by 1 plus Z bar, 1 plus Z plus 1 plus Z bar, the whole cube. Okay, 1 plus Z plus 1 plus Z bar, the whole cube. Now, here we know that cos square theta plus sin square theta is equal to 1. So, even this Z bar can be written as 1 by Z. So, we get 1 plus Z by 1 plus 1 by Z, the whole cube. Or we can write 1 plus Z by Z plus 1 into Z, the whole cube. I've just simplified it. So 1 plus Z into Z by Z plus 1 will get cancelled, and this will become Z cube. Z cube means actually sine 2 pi by 9 plus I cos 2 pi by 9, the whole cube. Can we directly apply De Moivre's theorem here? No. Okay. So I just selected this question just because I want to explain that part. So always remember, if you want to apply De Moivre's theorem, complex number has to be of the form cos theta plus I sin theta the whole raised to n. So I'm just going to write this as I into, if you take I as a common factor, will get cos 2 pi by 9 minus I sin 2 pi by 9, the whole cube here. So look at this. I into cos 2 pi by 9 is I cos 2 pi by 9, and then I into negative I, which will become plus sine 2 pi by 9. So if you take I outside, this will become minus. So now I cube into cos 2 pi by 9, the whole into 3. So 2 pi by 3. Shall I directly write 3? 2 pi by 9 into 3 will give you 2 pi by 3 minus I sine 2 pi by 3. Now, what is I cube? I cube is minus I, and cos 2 pi by 3. Cos 2 pi by 3 we had already found out in the previous question. It's minus cos pi by 3. So, minus 1 by 3, and here minus I root 3 by 2. Okay. So, just by comparing, what do we get when, let's expand this. So, we get plus I by 3, then plus I square. I square is negative root 3 by 2. So, we get, if you take this negative outside, sorry, plus I by 2. So, if you take this negative 1 by 2 as a common factor, you will get root 3 minus I. So the required answer will be option 3. Yeah. So the required answer will be option 3. Now let's work out on our next question. See, this is the type of question which I told you as locus problem. Let z be a complex number such that modulus of z minus 2i by z plus I equal to 2. And then z lies on the circle of radius 2 and center. We have to find out the center of the circle. So what we need to do is just take z is equal to x plus iy, and whatever is given in the question we need to work on it. Okay. So let z is equal to x plus iy. Now we are given that modulus of z minus 2i by z plus I is equal to 2. So let's write modulus of x plus iy minus 2i divided by x plus iy plus I equal to 2. So which can be written as modulus of x plus I into y minus 2 equal to 2 into modulus of x plus I into y plus 1. I hope it's clear so far, right? Now, what is actually modulus? Modulus is root of square, real part square plus imaginary part square. So we get root of x square plus y minus 2 the whole square equal to 2 into root of x square plus y plus 1 the whole square. To avoid these roots, let's square both sides. So squaring, what do we get? Squaring, we have x square plus y square minus 4y plus 4 equal to 4 into x square plus y square plus 2y plus 1, right? So let's do one thing. Let's simplify this. Let's take all the terms to the left hand side or right hand side. So we have a 4x square minus x square will give you 3x square. 4y square minus y square will give you 3y square. Then this is 8y plus 4y will give you 12y. And this is 4. Right hand side also we have 4. So it will get cancelled and this is what we get. Let's divide the whole equation by 3. So we get x square plus y square plus 4y. Let's just add 4 on both sides of the equation so that we can complete the square. So this is actually x square plus y plus 2 the whole square equal to 2 square, right? So this equation is of the form x minus h the whole square plus y minus k the whole square equal to r square, where this is a circle with center hk and a radius r. Center is hk and radius is r. So comparing our equation with this, what is h? H is 0. And what is k? K is negative 2. And r is 2. So we are given that z lies on the circle of radius 2. That's right. And what is the center? Center will be hk. And what is the center? 0, negative 2. So the required answer is option 4. I hope it's clear. Now, our next question, very similar question. If the center and radius of the circle mod z minus 2 by z minus 3 equal to 2 are respectively alpha, beta and gamma. So center is also given, radius is also given. We have to find out the value of 3 into alpha plus beta plus gamma. See, if you know the idea, definitely this was actual JEE Mains question. So you can understand how easy it will be. Only thing is that you have to be familiar with what we have to do. Okay. So mod z minus 2. As I had already explained, let's put z is equal to x plus iy. What do we get? Modulus of x plus iy minus 2 equal to 2 into modulus of x plus iy minus 3. I've just cross multiplied. So this is root of x minus 2 plus iy, x minus 2 the whole square plus y square equal to 2 into root of x minus 3 the whole square plus y square. Clear so far? Let's just cancel out the common factor, square both sides. When you square both sides, what do we get? X square minus 4x plus 4 plus y square equal to 4 into x square minus 6x plus 9 plus y square. Okay. X square minus 4x plus 4 plus y square equal to x square minus 6x plus 9 plus y square. Clear? So now let us just simplify this. When you simplify, what are we going to get? 4x square plus minus x square will give you 3x square. Then 4y square minus y square will give you 3y square. Then we have minus 24x minus 4x. So when you take it to the right hand side, you'll get minus 20x. And this is 36 minus 4 will give you 32. 32. See? Clear so far? Equal to 0. So let us write it in this form, x square plus y square plus, this is the general form of a circle. So x square plus y square plus 2gx plus 2fy plus c equal to 0. So for this, I'm just going to divide the whole equation by 3. So we get x square plus y square minus 20 by 3x plus 32 by 3 equal to 0. Now just by comparing, we have 2g equal to minus 20 by 3. So g is minus 10 by 3, or minus g is 10 by 3. 2f is 0, so f is also 0. So center is minus of g, that is minus g minus f. What is center? Minus g minus f, so that is 10 by 3 comma 0. And radius is root of g square plus f square minus c. So root of 100 by 9 plus 0 minus of c. So minus of c means minus 32 by 3. Okay, minus 32 by 3. So 100 by 9 minus 32 by 3. So how much do we get? 32 into 3. So when you simplify, we'll get uh, 4 by 9, right? 32 into 3 is 96. So 96, 100 minus 96 is 4. 4 by 9 is 2 by 3. So center is 10 by 3 comma 0. So this is 10 by 3, 0. And this is 2 by 3. And we have to find out 3 into alpha plus beta plus gamma. Okay. So 3 into alpha is 10 by 3, beta is 0, and gamma is 2 by 3. So we have 12 by 3 into 3. So the answer will be 12. Option 1 is the answer. Clear? Now, let's work out another one. The complex number. So here we are asked to find out the polar form of this complex number. Z is equal to I minus 1 by cos pi by 3 plus I sin pi by 3. So already our denominator is in the polar form. So I'm just going to write the numerator in the polar form, and then I'm going to simplify it. Okay. By using Euler form. Okay. So let's first write I minus 1 in the polar form. So I minus 1. I minus 1. So how will you write I minus 1? What is the modulus? R is equal to root of 1 plus 1, which is root 2, right? Root of 1, that is, here the real part is negative 1 square is 1, and also positive 1 square is also 1, so real part is root 2. And modulus is root 2. And amplitude, which quadrant this is like? This is real part and imaginary part is 1. So this is in the second quadrant. So let's first find out theta as tan inverse modulus of 1 by negative 1. So tan inverse 1 is pi by 4. But look at this, our complex number is in the second quadrant. So when it is in the second quadrant, we'll write pi minus theta as the amplitude. So the amplitude is pi minus pi by 4, which is 3 pi by 4. So our complex number I minus 1 equal to root 2 into cos 3 pi by 4 plus I sin 3 pi by 4. Okay, root 2 into cos 3 pi by 4 plus I sin 3 pi by 4. Now, we have to find out I minus 1 by cos pi by 3 plus I sin pi by 3. Now, in Euler form, we can write this complex number as root 2 into e raised to I 3 pi by 4, and in the denominator it is e raised to I pi by 3, right? So, this is of the form a raised to m by a raised to n. By law of exponents, we have a raised to m minus n. So, we can write it as root 2 into e raised to I into 3 pi by 4 minus pi by 3. So let's simplify. So root 2 into e raised to I 9 pi minus 4 pi, that is 5 pi by 12. 5 pi by 12. So we can write the given complex number as root 2 into cos 5 pi by 12 plus I sin 5 pi by 12. So which is the required answer? The required answer is option 1. I hope it's clear, right? Let's work out one more problem. Our next question is, yeah, let A is equal to theta, where theta is between 0 to 2 pi, 1 plus 2i sine theta by 1 minus I sine theta is purely imaginary. So given that our complex number, this is our complex number, 1 plus 2i sine theta by 1 minus I sine theta, we have to find out the sum of all the elements of A. We are going to take A as all the angles which will satisfy this condition. That is, this complex number has to be a purely imaginary number. Okay. A complex number is said to be purely imaginary if its real part is equal to 0. So what I'm going to do is, let me rewrite this complex number in the standard form. And which is the standard form? A plus IB. In the form A plus IB. And then take the real part as 0. So let's just write it as 1 plus 2i sine theta divided by 1 minus I sine theta. Write it in the standard form. For that, I'm just going to multiply the numerator and denominator by the conjugate of the denominator. What do we get? 1 plus I sine theta. You have to multiply the numerator and denominator by 1 plus I sine theta. So what do we get? Here, 1 plus I sine theta plus 2I sine theta minus, because I square is negative 1, minus 2 sine square theta divided by 1 plus I square is negative 1. So that's why 1 plus sine square theta. So this is the complex number. But we know that this complex number is purely imaginary. Purely imaginary means its real part is equal to 0. What is the real part of this complex number? Real part is 1 minus 2 sine square theta divided by 1 plus sine square theta. If this is equal to 0, obviously the numerator is equal to 0. That is 1 minus 2 sine square theta is equal to 0. 1 minus 2 sine square theta equal to 0 means 2 sine square theta equal to 1. 2 sine square theta equal to means 1 means sine square theta equal to half. Now if sine square theta is half, sine theta equal to plus or minus 1 by root 2, right? Plus or minus 1 by root 2. We have to find out all those theta such that its value is 1 by root 2 or minus 1 by root 2 in the interval 0 and 2 pi. So when you draw the sine curve, like it will be like this. Okay. So you'll get 2 points where the value is 1 by root 2 and 2 points where the value is minus 1 by root 2. This point will be pi by 4, obviously pi by 4. And this will be, okay, one will be pi by 4, next one will be 3 pi by 4. This will be 5 pi by 4 and 7 pi by 4. We have to add all these 4 values. I'll show you another method how to find out these these values. You know how to solve trigonometric equations. So if sine theta is equal to 1 by root 2, the principal value is alpha equal to pi by 4. And the general solution, I'll just deal with this in a different session. How to find out the solution of a trigonometric equation, we'll just deal with it in a different session. So general solution is given by theta is n pi plus negative 1 raised to n into alpha. So n pi plus negative 1 raised to n into pi by 4. So if you put n is equal to 1, we will get one value. Once we get that value, we have to check whether it lies in this interval 0 and 2 pi or not. And then we have to put n is equal to 1, 2, 3 and so on. Similarly, negative 1, negative 2 and so on. And check which all values lie in this interval. So here obviously we'll get 4 values. One will be pi by 4, second one will be 3 pi by 4, third one will be 5 pi by 4 and fourth one will be 7 pi by 4. So when we have 4 values, we just have to add them, right? We are asked to find out the sum of all these values. So Sum of all these values means we have pi by 4 plus 3 pi by 4 plus 5 pi by 4 plus 7 pi by 4. So when you add all these values, we'll get 12 plus 3, 15 plus 1, 16 pi by 4. 16 pi by 4 means the answer is 4 pi. So the required answer will be option 1. So now please try to work out as many problems from this complex number and get back to us if you have any doubt. Definitely I'll clear all your doubts. Thank you.